We're going to be talking about equations of parallel and perpendicular lines, specifically going through a given point. So in this first example, we're given y equals 3x plus 4. We want to write an equation of a second line that is parallel to this one and is passing through this specific point, 2 comma negative 3. So if we graph y equals 3x plus 4, we have a line similar to this. What we're trying to do is write the equation of a second line that is going through that point, 2 comma negative 3. So the second line's got to pass through that point. So let's write the equation of it. Here's how we do it. In order to write the equation of parallel lines, we need to have equal slopes. So if we look at this first equation, we see a slope of 3. Now that we have our slope and we know a point, we're going to be able to use the equation form called point-slope form. In that form, we're going to do y minus the y-coordinate of the point we want equals the slope, and in parentheses, we're going to have x minus the x-coordinate of the point we want. So here we have a double negative. Sometimes we need to simplify that. So y minus negative 3 turns into y plus 3. Otherwise, this is the equation of this second line passing through that point. Represented in point-slope form, we could take it one more step and represent it in slope-intercept form. That requires 2 steps here. We're going to distribute on the right. 3 times x is 3x. 3 times negative 2 is negative 6. And one last step, subtract 3 from both sides. And now we have our equation in slope-intercept form. And we can see it matching that y-intercept there and crossing through that specific point. All right, let's do another one. Exact same steps, different starting equation. Still going to write an equation of a line that's parallel to this one given. And this time we want that other line, that second line, to go through the point 4, negative 6. So looking at our first equation, knowing that we need to write an equation of a parallel line, we want to use the exact same slope. So we identify the slope in our first equation to be negative 1/2. Now we have everything we need. We have a slope and we have a point. So let's use point-slope form to write the equation. We're going to say y minus our y value, so y minus negative 6. That's going to turn into y plus 6. Equals our slope, negative 1/2. And in parentheses, multiplied by the quantity x minus our x value, which was 4 for our point. So we could represent that equation in point-slope form, or we could do a couple of steps and represent it in slope-intercept form. In order to do that, again, distribute on the right. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 4, that's half of 4, and a negative times a negative is positive. So we got positive 2. Last step, get rid of that, add 6 by subtracting 6 from both sides. And our slope-intercept form is y equals negative 1/2 x minus 4. We see that matching the y-intercept on our graph there. And it crosses through that point, 4 comma negative 6. All right, so that's writing equations of lines that are parallel through a given point. Last, let's write equations of perpendicular lines through a given point. Exact same steps, we just have a different relationship with our slopes. So starting with a given equation, y equals negative 2x plus 4, we're going to write an equation of a line that's perpendicular to that, passing through 6, 2. So our original equation, represented by this line, this decreasing line. We want to write a line that is perpendicular to it and goes through that point 6, 2. In order to write equations of perpendicular lines, we need to know that their slopes are opposite and reciprocals. So if we look at our slope that was given to us, negative 2, that could also be written as negative 2 over 1. So the reciprocal would be 1 over 2. Making it positive rather than negative takes care of our opposite. So our new slope is going to be 1 over 2, opposite reciprocal of negative 2. We have a point that we want to use, and now we have a slope. We're ready for point-slope form. So y minus the y value equals our slope, and in parentheses, x minus the x value. So there's our equation in point-slope form. To write it in slope-intercept form, we distribute on the right. 1/2 times x is 1/2 x. Half of negative 6 is negative 3. add 2 to both sides to undo that subtraction, and we get y equals 1/2 x minus 1. Drawing that line, we see it has a y-intercept of -1 and crosses through that coordinate that we wanted, and it looks perpendicular to our original line. One more time, exact same style of question, starting with a different line, y equals 2/3 x minus 1. Identify our slope. We want to choose a perpendicular slope to write an equation of a line that's perpendicular. So a reciprocal of 2/3 would be 3/2, and opposite of positive would be negative. So now we have a slope of a perpendicular line that we want to go through this coordinate, -6, 3. We have a point and a slope. We can write it in point-slope form. So y minus the y value, 3, equals our slope, -3/2, in parentheses x minus the x coordinate, so x minus -6. Minus a negative turns into a positive, so let's rewrite it and instead say x plus 6 there. So there's our equation in point-slope form. We could graph it that way or choose to put it in slope-intercept form to graph. Distribute on the right, -3/2 times x is -3/2x. -3/2 times 6 is -3 times 6, which is -18, divided by 2 is -9. Last step, add 3 to both sides, and we get -9 plus 3 is -6. So there's our final equation. In slope-intercept form, it's got a y-intercept of -6. It is perpendicular to that original line, and it does cross through the point given to us. So there's how we write equations of parallel and perpendicular lines going through a specific point. Just use that point-slope form equation. One last thing, in order to do our assignment today, we want to be able to use segments rather than lines. In order to do that, we're going to use an inequality statement that's going to say that our line is only going to exist between two values on the x-axis. So for example, here we have y equals -7, which is a horizontal line going through -7. We only want to draw it, though, in between -4 and 5 on the x-axis. So if you find -4 on the x-axis and trace it down, and find 5 on the x-axis and trace it down, then we know we only want our line to exist in between those two x values. So there's a segment rather than a line. We can do that also with diagonal lines. We could graph it, sketch it out here. If we start with our y-intercept at 6 and use a slope of -1 to trace a couple points, or a bunch of points here. And we only want that line to exist between 4 and 9 on the x-axis. So find 4 on the x-axis, trace up to your line. Find 9 on the x-axis, trace down to your line. And know that we only want to draw our line in between those points so that we're in between 4 and 9 on the x-axis. So there's a segment rather than a line diagonally. All right, so there's how to draw a segment using inequalities and how to write equations of parallel and perpendicular lines. Good luck practicing.